Okay, so anybody that's struggling with dimensional analysis, which is essentially just the units at the ends of any problems, can use this video. So let's look at the problem here. The period of a pendulum is given as t equals 2 pi square root of L over g. T is measured in time units, and L is the length of the pendulum, and AG, or g, is the acceleration due to gravity, which has units of length divided by time squared. Check this equation for dimensional consistency. So let's start by finding the important information in the problem, which is how I always like to begin my problems so I don't make any stupid mistakes. So right here's our equation, 2 equals 2 pi squared square root L over g. We have t is measured in time units, and if you know your SI units, time is seconds. So over on the side we can just write t equals s for t equals seconds. L is the length of the pendulum, and the SI unit for length is always meters, so L equals m. And AG, or just g, is the units of length divided by time squared. So g is equal to meters per second squared. And if you set up the equation as 2 equals 2 pi root L over g, and you just substitute in t for seconds, length for meters, you get seconds is equal to 2 pi square root of meters over meters per second squared. So you can start out by canceling out the 2 pi because as constant values they don't have units, so those are gone. And you're left with seconds is equal to root meters over meters per second squared. And meters divided by meters is 1, so you cross that out. And you get seconds is equal to the square root of seconds squared. And any number squared to the square root is just the base number. So you cross these out and you get s equals s. And you have just proven the dimensional consistency of the equation of the period of a pendulum.